Hello DevOps people, I'm Jochen. Welcome to my live coding stream, which I'll do every week on Tuesdays and Thursdays. In this live stream I'm doing DevOps work of all kinds, mainly work on my open source application that I've created for this stream. It's called Jupyter, and it's going to be a management software for IT infrastructure. So far, I've built a bit of functionality to import server information from the bare metal server provider Hetzner in Germany. Today I'd like to clean things up a bit and also try and deploy the application to a local Kubernetes cluster. Because now that we have a bit of functionality in it, it's time to deploy it and even try and use it in production as far as that's possible. And that's why I'd like to tackle the deployment issue quite early. Before I get started, as always, please try and be interactive. I'm very happy about everyone who joins me in the chat. If there's anything you'd like to know, if there's any question you have, if I'm doing things that you don't understand, or if you'd like to get an explanation of the things I'm doing, simply give me a shout and I'll be happy to respond. That being said, let's get started. What I'd like to do is first clean up things a bit. Let me see if I haven't yet started a tmux session, so I'll do that now. I'm still in the Hetzner import branch, and I guess I should first clean up things here a bit. Let me see, it's been a few days since last Thursday, so I'll have to reorient myself a bit and have some tea. Okay, so the importer has been finished. It's just not wired into the user interface. Last time I simply ran it from the Rails console. But that's okay so far. Of course, eventually I'd like to have a button there that simply lets me import stuff, but or even a job that does it regularly automatically. But so far I think it's a nice little minimum viable implementation. So I guess I'll simply commit this. What did I do with the rake file though? Okay, I simply added the Rails option to Rubocop. Which reminds me, are there any Rubocop issues still outstanding? I think there were a few lines too long issues that were still in need of resolving. Nope. Okay. Awesome. I fixed everything after the stream last week. Good. So I guess I can make a few commits here. let's name it basic. Hetzner importer. It could be more sophisticated, I readily admit that. Okay. So let me see how this looks against the master branch. Okay, it's the Hetzner server scaffold, it's the Hetzner server import service object. So I guess... Hey Marcus, welcome to the stream. Nice to have you here. I'll leave this separately and I'll make this a fix-up of the previous thing. I guess I merge everything together and then simply rewrite the commit message. Hetzner server. Send data import. This change adds a API class and service object. Hetzner server model and a Hetzner server import service. Populates. Let's start a new sentence here. For storing server information. A Hetzner import service populates and updates the database with information requested via a Hetzner server API class. I think that describes it. Okay-ish. Let's push this a final time. I'll also run the tests. In order to run the tests, I need to spin up my Docker containers here. And while the Docker containers are starting, I'll take a look at how my database reset break task is named in this project. I haven't even launched code, obviously. Docker DB reset. What I'd like to do is... Oh, that's not even complete because I don't... I reset the dev database but not the test database. So let's do this differently. using the DB namespace, and then we'll use a task named nuke, and that will run this part here, bundle exec. Rails DB migrate reset, that which completely nukes the database and creates and runs all migrations again, and DB seed will then populate the database with development test data, and then we'll run almost the same thing, but only the reset part for the test environment. I guess I'm still in VI mode here. I remove this part here. That way I can run a rake db nuke inside the container if I like. Inside the existing container or inside a newly spawned container. That should run fine here. Okay, have I got an app container? I do, so I can run docker compose exec app rake db nuke. The song that's running in the background is by an artist named Abstraction, and it's the album name is Covered in Cats, which sounds to me like something I would enjoy in this season. It's getting a bit cold. Okay, so time to run our rake task. Simply run rake, which will run the test suite by default. And I'll go ahead and I think the last commit I did was, oh yeah, that's a different change in the rake file. So let's let's call it reset. No vulnerabilities of my current gem set. Okay. Robocop shouldn't complain either. It always takes ages to start Robocop. So how is everyone? I'm pretty good. As I said, it's getting cold here in Ireland, but not as cold as elsewhere. I just got a message 2 days ago from someone spending a few days in Finland, and she took a video from a dog sled, which looked amazing. That's something I'd like to do eventually. Dog sled across Finland. And then get something warm around me and probably a nice whiskey in my hand. This very slow cop here. At least it doesn't complain. Let's see what Rails best practices has to say. Shouldn't find anything either, but it's always good to run these tests before merging them to master. At a later time, I'll integrate a Travis CI that will run these tests automatically when I merge into master. So if I'm oh, see, it does complain. If I'm confident that things won't that these tests will succeed, I can simply merge to master and then everything will run automatically. But in this case, it didn't succeed. Yeah, I had this earlier, that Rails best practices doesn't like instance variables getting passed or used in views. So let's take a look. It's Hetzner servers form HTML. And fortunately this is easy to fix. I simply use a local variable instead of an instance variable inside the view, and since the view then uses f for referencing everything, I'm already done, and now I just need to go into the control into the edit form, edit template, and change things there. I'm not exactly sure how did I do it here. Okay, this is a local variable. How did I reference that? In the same way. That's awesome. So I should still be able to call this. Nice. So let's see. If I go into my Docker container, later this should also be covered by integration tests that I can simply run instead of doing manual checks, but for the time being, let's simply check manually. So I go into Hetzner servers, new Hetzner server, number 123, name test, IP 1234, create. It did create it, do edit. It works. Well, that's awesome. That was easy. So I go ahead and run the tests right away and simply commit them in another shell. Replace instance var with local var. Go ahead and push this. By the way, the repository for the application is open source, and so you can take a look at it or even clone or download it yourself from github/gvis/Jupyter. Now let's wait for the tests to succeed, and then we can go on. What I'd like to do is deploy this application to a local Kubernetes cluster or instance that I'm running in Docker for desktop. I think I haven't yet enabled it, so let's do this. I hope I'm not running out of memory by running a few Docker containers alongside a Kubernetes instance. Gone are the days where 16 gigabytes of RAM were plenty. Oh, fade to start. How sad. I wonder if I can find out what went wrong. Well, the Docker machine should have more than 4 gigabytes, shouldn't it? Okay, let's shut down my running containers. And I've already pushed my changes, so I should be able to merge them into master. I did resolve the number 13 issue here, so that should take care of things. Okay, so we can clean up. That's that. And I shouldn't have. Oh. Number 11 was resolved already, right? Yep. Okay, so I can delete the 11 branch as well. That's the main advantage of naming your branches with a reference to an issue. That way you can always determine if this branch still has valuable data in it or if it can be removed. And I guess I can now focus on issue number 3 here, set up Kubernetes deployment. Let's see if Kubernetes is able to start now. In the meantime, I'll go ahead and research how to deploy a Rails application to Kubernetes. Deploy Rails to Kubernetes. While I have an idea how this should work, I'd rather check things out, how they are supposed to run. Okay, it did start this time. Okay, this is using mainly GKE, but that's what I'm interested in here. Deployment. This is the web application using an image that it gets pushed to the Google registry in this case. Using Passenger, well, we will use Puma, I guess. All sorts of things. Yeah, we'll have to populate a lot of environment variables. They use a Cloud SQL proxy here. Don't know why. It's mostly GKE, so that's not exactly what I'm looking for. Let's take a look at this. Deployment, Rails, app, image, container port 3000, yeah, that's more like it. Database URL, which we'll have to store in a secret. And an environment variable for the secret key base. Okay, yeah, makes sense. Then a service, in this case it's either node port or load balancer. In my case it'll be neither, because I'll put an ingress in front. Okay. They use Minikube to test things, and I'll use Docker for desktop. That doesn't make a big difference. Okay, that's the Rails application, and then I'll have to deploy Postgres and Redis. Especially Postgres, I think. I'm not sure if this application actually is already using Redis. It might be because of the asynchronous worker implementation? Not sure. Okay. So let's start with this. Okay, so I'll create a new branch as always, and I'll simply name it 3Cube for Kubernetes. Why not? New branch. Okay, and I'll put my deployment manifests into the K8s directory. So let's see, here we go. K8s. It even has a Kubernetes icon here in VS Code. That's amazing. So we call this app deployment YAML. So it's the Jupyter deployment. 2 replicas should be more than enough. We call the application Jupyter.
Our struggle as artists isn't about appeasing the crowd. Rather, it's about tending
We
to
can still
broken
keep
hearts
Rails up
inside
in
of
this
us.
case. We'll have to replace the image though.
We create things as a reflection of this struggle.
And
Study our perception of self.
we'll have to create the 2 secrets here.
Then wave isn't necessarily a thing you achieve. Rather, it is a state of mind which you constantly strive toward. This all comes from an understanding that ideas aren't static, but fluid, like water. Be like water.
Okay, we'll leave this way until we know how the Postgres deployment looks like. So I guess I need a new file, which I'll call PG deployment. And I'll have to write down how to create these secrets. I'm curious how Shopify goes about these things, because they are huge Rails and Kubernetes users, and huge even in a literal sense. Namespace. Pre-deploy and things like that is something we'll have to take into account. Also, things like running tasks at the beginning of a deploy with an init container, for example, to set up the database. But I'm not going to use an external tool for this yet. I'd like to do it from scratch. Okay, let's see. Deploy Postgres to Kubernetes. I also don't really want to use Helm. because even Helm seems to hide a lot of things. I like this, with using a config map to store certain things. Well, probably you wouldn't want to use a config map exactly, because that's something that belongs into a secret. Config maps aren't the proper thing to use here. Yeah, we'll need a persistent storage volume as well for the database, that's right. And that's where it's getting a bit more complex. So what they do here is they create a persistent volume in the upper half of this file, and then they go ahead and you create a persistent volume claim in the lower half. Obviously these things are related, but from a DevOps standpoint, these are very different things. The upper half is about providing the storage space for the database, and that's something that's done by the ops side of things. And then the second half is about using this storage in the form of this persistent volume claim, which obviously is related to the application and therefore done by the dev side of things. So from my point of view, while it's pragmatic to bundle both things in a single file, in a production environment, these two things might not be able to live in the same file, because a developer might be able to claim storage, but might not be able to provide their own storage. That's something that needs to be done maybe by someone who has completely different permissions on the Kubernetes cluster than the person who then goes ahead and uses this storage space. So what I'm going to do is I'll use two different files here. If I'll even provide a persistent volume manifest at all. We might even just document that this deployment needs a persistent volume of a certain class, which is the storage class name here. So we could say, okay, we need a storage class, in this case named manual, and it has to provide at least 5 gigabytes of storage, because that's what we are going to claim. And from this documentation, an ops person would be able to create a persistent volume that fits the bill. Okay, so, oops, what happened here? This has grown a bit, hasn't it? Let's reload the page. So, let's start with this. We obviously need a PG PVC, persistent volume claim. Should also provide an API version, I guess. Persistent volume claim v1. Okay, that's just a different order here. And we'll call it Jupyter PG PVC. Okay. And here's the Postgres deployment. I'll just copy it to my repository here, so we'll call it Jupyter PG. One replica, yeah. Jupyter PG container name Postgres, we'll use 10.4, that's alright. If not present, 5432, and we'll have to use another way to provide the passwords and stuff. And then the mount varlib PostgreSQL data from the PostgresDB volume. And we call this Jupyter PG storage. And how do we reference this? It's the Jupyter PG PVC.
What are you afraid of?
I'm lost in old ways.
Let's call it PG data. So it relates to the data directly here. Okay. So we probably use something like this. We'll use env, and then we'll have to provide a few environment variables that we'll take from secrets. Okay.
They talk about another kind of world. Another kind of world.
Let's provide the persistent volume manifest as well, even if only for
I'm lost in old
as an
ways.
example. PG,
I'm not afraid.
PE, YAML. How is it referenced? It's, oh yeah. Jupyter storage. You have to provide a local path on the Kubernetes node to use here. And the persistent volume, we'll just call it Jupyter PV, I'd say. And we'll associate it with the Jupyter PG app. And there's also a special annotation we'll have to use, though, that it gets created on the right node automatically. Okay, and in here we'll use Jupyter Storage as the storage class name. Let's call it Jupyter PG Storage. Okay, that's that. Does yeah, let's which environment variables do we need? We need a DB name. And then we'll need user and the password, right? Okay. The database URL should be built from these parts. I'm not sure how to do this in the manifest. I'll have to look this up. By the way, if you have any hints, I'm more than happy to accept them, if that's something you've done already. Let me see. Let's go ahead and document the deployment. So we'll first have to create a Rails secret. And then we'll encode it. Oh, of course, yeah. Okay, and then it's good. It's the base 64 encoded secret then is so we can go right ahead and then base 64 encode this and then pass it on to a Kubernetes secret command, right? Kubernetes secret. Creating a secret using kube control. Create secret. I always had to create a YAML file for this. I find this strange. Yeah. Kube control doesn't have a secret command. Okay. But it has a create secret generic command. Okay. Create secret generic with a literal value. Not from a file, from literal. Okay, that's what I'm looking for. So I basically can do something like kube create secret generic Jupyter secrets, I think. Yeah. And then I'll say secret key base. Equals and then we'll do a bundle exec secret and base 64. This and we'll have a few more things. It gets unwieldy, doesn't it? Well, let's see. I don't need this one. Which other keys do we need to create? In this case, we'll somehow need the database URL, but I'll see if I can puzzle that together from the different details we'll give to the Postgres deployment, which is the Postgres DB. I guess we'll just call it Jupyter. Use the user. Oh, I can make the music a bit lower. Let me see if I can make the music a bit less loud in my streaming software. Ah, here. I've reduced it to 80%. Let me know if that's okay or if I should lower it even more. The user will be named Jupyter as well, and then we'll just need to provide a password. I guess we can leave this to the person that runs the kubectl command, or well, maybe later I'd like to use OpenSSL to create a random password or something like that, but I'm not in a mood to go into these details too far. Let me see what time it is. Yeah, half an hour to go, so let's see if we can get this to work. If I run this command like as it is, where am I connected now? Current context. Oh, I'm connected to our production cluster. That's not supposed to be the case. And so let's switch to Docker for desktop. Are there any pods running at the moment? No. Okay, so let's start by simply running this. So we have a problem here. Exactly one name is required. Got two. See. Kubectl create secret generic name. I guess that's what they are referring to. And then I'll just do a few from literal calls. So that's the command it tried to run. kubectl create secret generic Jupyter secrets from literal secret key base equals. Oh, my backslashes get. Oh no, the backslashes don't matter in this case. Or do they? No, they don't. Let's take another look at the help. I don't see where my problem is. I have exactly that. kubectl create secret generic, the name Jupyter secrets, and then from literal equals equals value, and then we go on from there. Let's try a dry run. Oh. What's happening here? It doesn't actually concatenate these lines. It tries to run from literal as a different command. So if I go ahead and put them into one single line, it will run? Huh, you must be kidding me. Get. There's 4 data entries. What the heck? Why doesn't this work? Is it a single backslash? Is it getting this Oh, it's getting late. If I can't even get my basic bash syntax right, it's really time to take a break. Huh. Okay, so let's run the actual command then with the random rake secret. Already exists. Okay, yeah, well, let's delete this one. Cube cut will delete secret Jupyter secrets. And then create it from scratch. Okay, that's better. Is the music okay now? I'll simply leave the setting on 80% then. Let's take a look at... Yeah, okay. Then we'll need to create a persistent volume. Okay. I'll also have to look at the application host environment variable if this is really necessary. That's something I probably inherited from the suspenders framework that I used to create the application. Okay, so now that I have the secrets in place, let's find out if I can reference multiple secrets in one piece. We can mount the secrets. Or we can use them as environment variables. Okay. So I guess the question is, can I reference other environment variables in an environment variable definition that's not directly related to secrets at all? Using environment variables inside of your config. Okay. That looks interesting. That you define in a pod's configuration can be used elsewhere in the configuration, for example in commands and arguments. This is just for the pod's containers. In the example below, the greeting, honorific, and name environment variables are set to some variable respectively. These environment variables are then used in CLI arguments past the end print demo container. And that's actually, I think, part of YAML. Okay. Looks familiar. I think I've run into this before. So this means I can actually go ahead and in the Postgres deployment, in the application deployment, I'll use a literal value, and now I'll have to find out how the URL needs to look like. I think it's PG, and then the host, okay, and then /rails after the database name, okay. Straightforward. So in our case, that's I think it's Postgres, and then okay, I need to get the values first, just as I do here. We'll get the database, we'll get the user, which needs to be okay, and then we can use these values to use Postgres user, Postgres password at the name should be the name of the service, so we'll name it, the service will be named Jupyter PG as well. Jupyter PG / and then the database name Postgres DB. That should do this, and you have to fix this here, and this is Postgres password. Okay. So that's a rough scaffold how this deployment is going to look like. I'll have to provide a Docker image. It's the same image that I'm running locally here, so I'll just have to upload the image somewhere, which will probably be key.io. And I've already created the secrets. We'll see if the database URL gets built correctly. And with that, we should be able to deploy the application. And in terms of Postgres, we already have the secrets in place. We'll have to provide the persistent volume claim here. And for this to work, we'll need to have the Jupyter PG storage class in place, which in turn is provided by this persistent volume, and we'll have to create the local storage volume on one of our Kubernetes nodes, which will be the only Kubernetes node in my local Docker for desktop setup. But that's something I'm going to do next time. I might give this a few tries and see if it'll actually work. But don't worry, you'll miss nothing. I'll definitely do this on Thursday. I guess it's a good time to wrap it up for today, because first of all, I won't get very far in the final 13 minutes, and second of all, I'm actually a bit tired and my brain gets a bit sluggish at the moment. Alright, so if there are any questions, leave them in the chat. I'll be online for a few more minutes, and I'll also go ahead and push this to my GitHub repository. Let's call this commit Kubernetes deployment manifests. That should do the trick. While you might still write something, I'll see if I can fix these markdown lint complaints. No multiple blanks, multiple consecutive blank lines. Okay, that's something I'm used to do, but Markdown lint doesn't like multiple blank lines in a row. Okay. We'll merge these commits later, but for the time being, I just go ahead and stack commits. Okay, and I'll also have to have a look if we also need a Redis container, but launching that one will be a bit easier, I guess, because we won't need a lot of credentials and stuff. And that's it for today. So, as always, thank you very much for watching. Thanks for being here all this time. And if you haven't yet, please follow the stream. It'll help me reach more people who are interested in this DevOps kind of stuff. And I'll upload a recording of this session to my YouTube channel as well. So if you go over there and subscribe, that I would appreciate this as well, because it helps me grow my audience. You'll find everything on my website at fullstacksensei.com. And if there's anything you'd like to know or comment or give me feedback on, you can also reach me on Twitter at fullstacksensei. Until Thursday, when I'm going to continue at 3:30 p.m. GMT. Thanks and take care.